Good morning. Good morning, my dear students, Prep 3. Miss you so much. I wish I could meet you again sooner, inshallah. My topic today is about nuclear energy. This is Unit 2, Lesson 3. This lesson is so important. As we studied before, electric energy. Nuclear energy is the type of energy. Okay, we should know. You have to know the main introduction to nuclear energy this year, as is the main chapter in chemistry in second round, inshallah. Okay, let's start with the meaning of nuclear energy. What is the nuclear energy? We have to know the meaning of nuclear energy. Nuclear energy is the binding force. Okay, nuclear binding force between atoms. As you studied before in prep, the atom consists of electrons and nucleus. Nucleus consists of protons and electrons. Okay, sorry, protons and neutrons. Protons has positive charge. Positive charge protons, there are repulsion force between them. So we have another type of force called nuclear binding energy to overcome the repulsion force between positive charged protons. And neutrons have the neutral charge, so it is not affect on the nucleus. What's the meaning of nuclear energy again? It's the stored energy in the atom's nucleus. It acts as binding the nuclear components together and overcome the repulsion force between positive protons. So it's known as nuclear binding force. Easy? Sorry. We have to recognize the radioactivity phenomena. Radioactivity phenomena is discovered by Henry Besquirel. Henry Besquirel was a French scientist, discovered the radioactivity phenomenon. Radioactivity phenomena discovered in 1896. What is the meaning of radioactivity? Radioactivity phenomena, it is the spontaneous decay of the atom's nuclei of some radioactive elements. Radioactive elements naturally present in the environment. Okay, to achieve more stability. Why the spontaneous decay of atom nuclei? To achieve more stability. So the atoms need to be more stable, like the excited atom. The excited atom, when lose some amount of quantum, return back to the ground state and be more stable. So atoms search for more stability position. Radioactive elements, they are elements whose atoms nuclei contain a number of neutrons, more than that required for stability. So it makes spontaneous decay to get rid of the extra neutrons. Okay? For example, radium, cesium, selenium, polonium, zirconium, uranium, rubidium. The most abundant one, uranium, or the most famous radioactive elements, uranium. I think all of you hear about uranium. Okay, they are radioactive elements naturally present in our environment. Easy? Okay, but we can get artificial elements or artificial radioactivity. Artificial radioactivity, it's present in our nuclear labs or science labs. It's a radiation or nuclear energy that released during nuclear reactions. During nuclear reactions, there are two types. They come from nuclear reactors, it's the safe users, or from nuclear bomb and military uses. What are the peaceful uses of nuclear energy? We have many fields of uses of nuclear energy. In medical field, How can we use the nuclear energy in medical field? We use nuclear energy in discovering and treatment of cancer cells. Agriculture field to get rid of pests and improve the crop production. Industrial field, for example, to overcome the defects on the products. Electricity generation, the electric generations, like what happened in waterfalls, for example, or turbines, like turbines generate electricity according to the change from hot and cold water and steam in nuclear reactors. And space exploration and drilling field, drilling about water, petroleum exploration, or space exploration like aircrafts which fly in space. Okay, is it easy? Electricity generation in electric reactors is a simple diagram only for illustration to show how the electricity come from turbines and generators due to the steam out and steam in cold and hot water. The nuclear reactors have very hot water. As pass through turbines or condenser, it will be a cold water and at the same time generate electricity. Okay. But as we use nuclear energy in large dose, it causes radiation pollution. Uh, Radiation pollution divided into two main types: natural sources and artificial sources. Natural sources come from natural radioactive materials found on Earth's surface. Cosmic radiation that comes from the outer space. This is a natural. We can't do it. Artificial sources, this is man-made according to man activity. For example, the explosion of nuclear, the explosion of nuclear bombs that some countries do as experiments and according to the nuclear reactors. This is due to man activity. Okay. For example, explosion. This is the example of artificial radiation. The explosion occurred in the Russian reactor at Chernobyl is an example of radiation pollution in April 1986. Radiation pollution affects the human body health. So we have a lot of effects. For example, physical effects, genetic effects, cellular effects. Physical effects, it affects on the type of cells as it causes cancer cells. For example, skin cancer. How the nuclear radiation causes skin cancer and at the same time it is used in medical field as treatment and discovering cancer. Yes, it depends on the amount of dose of nuclear energy, amount of dose. Okay. Genetic effects as it causes abnormal cells. For example, the pregnant woman who exposed to a large dose of nuclear energy, maybe the baby has abnormal characters, abnormal shape. For example, has 6 fingers instead of 5 fingers. Okay. Cellular effects. Cellular effects. It affects the cell composition, like hemoglobin cells. Hemoglobin cells hemoglobin comes from red blood cells. The red blood cells, if takes place defects in the red blood cells function to carry the oxygen and food from inside our body and get rid of carbon dioxide and wastes outside. If there is any defect in red blood cells, so it causes the inability to be enabled to carry oxygen well to our body. So it causes a lot of diseases. Okay, so we have three types of radiation effects of human body, physical effect, genetic effect, and cellular effects. That's right. We have to know the meaning of isotopes. Isotopes, they are atoms of the same element that contain the same number of protons and different numbers of neutrons. So it results in the different mass number. As we studied before in Prep 1, any atom has mass number and atomic number. Atomic number equal number of protons or number of electrons, as the number of protons and electrons are equal. Okay, the mass number, it, it is a summation of number of protons and number of neutrons. So if the number of neutrons are different, so the mass number will be different, so the atoms will be different. As we have isotopes, for example, we have hydrogen, the normal hydrogen, hydrogen 1 atomic number and 1 mass number. The isotopes of hydrogen, H1, 2, and H1, 3. They have different numbers of neutrons. Another example, oxygen. The normal oxygen, O6, O816. Atomic number 8 and mass number 16. The isotopes of oxygen, O817, O818. They have different number of neutrons. So they are called isotopes. So you know the meaning of isotopes again? Isotopes, they are atoms of the same element that contain the same number of protons and different number of neutrons. And now we will recognize the international measuring units of nuclear radiation. The international measuring unit of nuclear radiation is SIEVRT, SV. Like the international measuring units of mass, for example, kilogram. International measuring unit of length is meter. So the international measuring units of nuclear radiation is SIEVRT. Now we will recognize the safe dose of nuclear radiation. For radiologists, the scientists who work in nuclear reactors or deal with nuclear energy, the radiologist's dose, safe dose is 20 millisievert. For public, for all of people, for us as a general, is only 1 millisievert. So if we expose to the dose more than the safe dose, we have radiation pollution. Easy? Okay, now we will know well the nuclear energy or nuclear radiations have useful effects and harmful effects. How to protect ourselves from radiation pollution. We have means of protection from radiation pollution. For example, number one, the workers with radioactive elements in labs and hospitals should wear radiation protective cloths. As doctors, for example, as we are in science labs, wear our white coat. So the workers or people who work or deal with radioactive elements must wear radioactive protective clothes. Follow the precautions while dealing with radioactive wastes. And pairing of nuclear waste is so important. Nuclear wastes pollute the water, air, make a lot of pollutions according to the radiation power emitted from it. Issue laws for nuclear stations to cool and hot water, to cool the hot water before throwing it in sea and lakes. The hot water comes from nuclear reactors must be cooled before throwing in sea and lakes. So if we follow these instructions, we can save our bodies from radiation pollutions or nuclear energy radiations. Is it easy? I think this is enough for this lesson to know this information. And now we will solve some page 52 in your booklet. Okay. The homework will be page 53 and exercises in the school book. And now I will solve page 52 with you as an exercise about this lesson. Okay. Open your booklet, please. Worksheet 6. Worksheet 6, page 52. Question number 1, write the scientific term. This is a spontaneous conversion of the atoms, nuclei, the same elements, nuclei in nature, to achieve more stable composition. The definition of what? Radioactivity phenomena. Please write with me, radioactivity phenomena. Finished? Okay. Number 2, it is the radiation produced from radioactive elements present in nature. It is the definition of what? Natural radioactivity. Radiation produced from the radioactive elements present in nature. So they are natural radioactive elements. So it's natural radioactivity. Is that easy? Okay. Number 3, the radiation or nuclear energy that is either released during nuclear reactions that can be controlled and is conducting in nuclear reactors or released from nuclear bombs. Is the definition of what? Artificial radioactivity. Spontaneous conversion, natural radioactivity. But radiation comes from nuclear reactors or nuclear bombs, it is artificial radioactivity. Yeah, finished? Okay. Number 4, they are the atoms that contain the same number of protons, but different number of neutrons. The definition of what? Isotopes. That's right. This definition of isotopes. They have the same number of protons and different number of neutrons, like hydrogen and oxygen. The measuring unit of radiation absorption. Sieverts. Sieverts. SV. Okay. Number 6, the change that appears on a living being as a result of exposure to radiation. What type of this effect? Cellular or genetic or physical effect? This is the physical effect. Okay. Change that appears on living being as a result of exposure to radiation is the physical effect. Question number 2, give reasons. The area chosen for storing radioactive waste should be stable, or away from homes or away from people. Why? To avoid dangers of radiation pollution. That's right. Number 2, radiation has genetic effect. What is the meaning of this question? This question needs to describe the genetic effect. What is meant by genetic effect? Radiation has genetic effect as it affects the sex of composition of chromosomes that cause abnormal newborn baby. That cause abnormal newborn baby. Is that easy? We had finished page 52. Please answer page 53 again and exercise in the school book. Thanks a lot for you and have a nice day. I will meet you again, inshallah, in next session. Please study well and answer the homework and send it to me through your Google email. Okay? Goodbye. Bye.